Yes, thank you for recording. And before we begin, we will take a picture together. Please turn on your camera, guys, and make sure your uh, nickname already like Viola. But Viola, your nickname is not appropriate. Also, Mentari Rahma. The correct one is Gabriel is okay. Lim Guan Kun is okay. Anissa is okay. Please change your nickname. Oh, if they don't hear us, means they don't monitor. Siapa yang ambil picture? Alif, Ibnu?
Bisa tuh, Pak.
Yeah. Jelasan, please remind the participant to change their nickname accordingly. Mbak Hanan juga stripnya masih salah ya. Yang benar seperti Lim Guan Kun, Gabriel itu benar, Anissa itu benar. Ya silakan turn on your camera guys. Silakan Ibnu.
Baik. I will start screenshotting in 3, 2, 1. All right. One more picture. 3, 2, 1.
Thank you.
Oh, yes. Good one.
All right, guys, let's begin our final session. Well, not final actually. Density functional theory. Dr. Vera, can you hear me?
Yes, we can hear you, Dr. Fabian.
Like usual, before we begin a new material, we always repeat what we have done last week. Why? Well, it is common in educational theory that it is important to repeat several times when we begin the new material. Wait, so many messages here. What we have known so far, traditional chemistry up until 1890s have already led people to prosperous. What does it mean? What I meant by that is before 1890s, we didn't know quantum mechanics. We didn't know quantum theory. We didn't know modern art of modern physics. But chemistry already so far to contribute to our prosperous. I will give you 3 achievements by traditional chemistry that changed the world. What is it? What were there? First, fertilizer. Fertilizer. It changed the agriculture. Second, vitamins. Multivitamins with mineral, like what you saw that in the other advertisement, this advertisement. These two things achieved by traditional chemistry, chemistry without quantum. They already know how to make fertilizer. They already know how to make vitamins to improve our food and also our health. Amazing. And the most important achievement of traditional chemistry is no other than oil refinery. And I meant to put this figure to remind you guys. If you don't know yet, then you have to look at to the Wikipedia. Who is this guy? His name is John Rockefeller, the founder of Standard Oil in United States, and it links to Zionists. I told you. There is no Standard Oil anymore, but we have Chevron, we have BP, we have what else? Exxon. It's all come from Standard Oil. So this refinery oil technology, John Rockefeller gathered all the best chemists in that time to come up to the idea how to refine oil, gas and oil. You know that when we take oil from our earth, it is not pure. We have to clean it. A lot of impurity. And there were traditional ways to do that, but Standard Oil came with a very smart way, with a large scale, large industrial scale to do oil refinery. And finally, in the end, we have petrodollar. It comes from this guy. So 3 things that I show it to you, that to emphasize to you that actually we are enough already. We already have everything we need with traditional chemistry. Even though, I told you already, even though it was excellent, but that was not enough. Why it was not enough? One of them is that the traditional chemistry cannot explain the symmetry of ozone, not to mention the structure of benzene and other conjugated bonds. We have discussed this already, and this is what I meant by conjugated bond. The double bond alternate with single bond, double bond, single bond, double, single bond. There is a song about that, you know that, right? Understanding the molecular geometry is the key of drug design, material science, and catalyst technology. I repeat, understanding the molecular geometry is the key of drug design, material science, and catalyst technology. These 3 things is, well, that's the basic of what we have on all of technology right now, based on these 3. Drug design for our health, material science for our technology, or gadget, computer, and so on, and catalyst is for the reaction. Of course, it is a debate material. Do we really need them? Our grandparents were so happy with their world. There was no internet. They were happy. There was no airplane. Well, airplane was there, but expensive. Everywhere they go by bus, by bicycle, and they were happy. But now, even you guys, you still a student, but you have a lot of problems. During that time, in your age, our grandfather, they're already rich. They have their own farms. But what you have now, except debt, hutang? Nothing. So we got a problem right now. So that it is a material for debate. Do we really need to understand molecular geometry? In my perspective, one of the reasons why we have so many problems right now, because we understand geometry, but we don't use our understanding wisely. So that's why we have many problems. Just because single bond, double bond, single, double bond. Because of that, you have Dr. Farah to sing. There is a time that Dr. Farah will sing. Don't worry. Last year, she songs Wulan. I don't know about this year. What songs that she will sing. All right. Physics came to rescue. Resonance in couple pendulum. We discussed about this. One pendulum is oscillating and transferring its energy to other pendulum by oscillating the spring. Like this, right? This is moving and then transfer energy via spring. And then finally, A is at rest. B now is begin oscillating. Oscillation is wave indicates, if you see something is oscillating, indicate wave is propagating through a medium, through that thing. All right? In other words, energy transfer in the form of wave. Energy is transferred in the form of wave. The moving pendulum was slowing down. A is slowing down. And other pendulum, B, began to oscillate. And it is repeating process. Now B transferring energy to A, B begin to slow down, and A now is start to oscillate. And the process keep repeating. That's why in physics, definition of resonance is the interdependence position. Position of A depends on B. Position of B depends on A. All of these things happen, the resonance is possible because the energy transfer. All right? Now, we borrow that idea to understand the resonance in H2 plus, H2 plus or hydrogen ionic molecule. There is no spring inside H2 plus, but we have one electron orbiting one of the nuclei. Either it is orbiting at A or at B. It is possible one electron orbits from one to another and then move to, first it orbiting A, and then move to orbiting B, and then move back to A, and then move back to B, and so forth. It is possible if there was energy transfer. So what we already explained just now is resonance. Because now position of A depends on A and B. Position of electron 1 depends on nucleus A and nucleus B. Since there was no spring, electron must act like spring for itself. Before that, we have real spring. So the energy transfer via the spring. But now there is no spring. So the electron must act as a spring itself to transfer itself from A to B, from B to A, vice versa, and so forth. It is possible if and only if the electron behaves like wave. And the unique of wave, it can interact with itself. I already explained to you, we call it self-interaction. Why wave behavior special? One of 7 wave phenomena, there is only 7 phenomena from wave, only 7. No more than that, only 7. 6 of them due, 6, right? 4, 2, yes, 6. 6 of them occur because wave interact with particle, with matter. Wave interact with matter. For example, reflection, refraction, diffraction. Okay, but 1 of 7 occur because wave interact with wave. If there are two waves each other, we call it superposition. Like what we see here. This is two kind of wave. Wave from hole A and wave from, and then we will have them interact in the middle. That's why we have, light, dark, light, dark, light, dark, light, trend. You can Google it, check with the keyword co-host, please help me. If there is someone enter, please click. Otherwise, it interrupts my slide. Yes, I will give my host to, let's say, who is the most stable person in this room. I hope there is Rizka Sang. Rizka, are you there? Ah, yes, Rizka. Rizka, I will put you as a host. Is it okay with you?
Yes.
Yeah.
Definitely.
Otherwise, every single person can interrupt my slide. Please help me. All right, thank you. Now, please give me access to share.
Yes.
Thank you. All right. If you want to know more about this figure, you can Google, you can find in internet with the keyword young double slit experiment. Young is the name of the person, Thomas Young. Doesn't mean the split experiment is muda. It is not muda, okay? It is young. It is the name of the person. So, of course, what we see here is interference, but the interference occur two waves interact each other. Interferensi adalah fenomena yang terjadi karena gelombang berinteraksi dengan gelombang. Dari 7 fenomena gelombang, 6 diantaranya terjadi karena gelombang berinteraksi dengan materi. Gelombang berinteraksi dengan materi. Kecuali satu fenomena terjadi karena gelombang berinteraksi dengan gelombang yang lain, seperti eksperimen Thomas Young, celah ganda. Pada celah ganda, kita bisa melihat celah ini sebagai dua sumber gelombang. Dua sumber gelombang yang identik. Frequency, the wavelength, and the amplitude, also the phase, are exactly the same. So basically, what we see here is the superposition, penjumlahan dua gelombang. Sometimes the summation, the superposition, penjumlahan dua gelombang may get constructive, saling meninggikan amplitudo, or destructive, saling menghilangkan. Alright? Makes sense. But what happened, even when we have only one source of wave, the interference still occur. That's crazy. Why? If there are two waves, then makes sense when they interact each other and construct the interference trend. But if we have only one wave, there is no way the wave will interact with itself to interference. But in fact, that's what we see. Wave can interact with itself. So we still see the light and dark trends, even when we only have one slit open. That's crazy, right, Dr. Vera?
Yes, Dr. Fabian.
You cannot think, even you have 5 PhDs, you cannot explain this. This is the nature of wave. Nobody can explain this. It interacts with itself. It's crazy, guys. Like you talking by yourself, you talk with yourself. If people see you talk with yourself, you are crazy. If someone say you are crazy, say I am wave. I am behaving like wave. So you are not crazy anymore. Even though we agree that it is crazy enough, it is crazy, but there is another thing more crazier than this. What it is? Electrons also interact with itself. Please Google the experiment called Davison-Germer experiment. It is a long experiment. I don't have time to explain to you, but I found this meme very good to explain the situation. What we see here is two slits, so like a double slits, but now you shoot the hole with electron beams, not light anymore, not light, but electron beams. Sinar electron. When you only see the initial and the final, only see, just should capture the result, you will see the interference pattern. You got shocked. Hey, what happened? It is not particle, it is not wave, it is particle. And you have to check it carefully where the electron goes, either to hole A or hole B. You make some experiment design, you measure it, you very accurately where one electron goes. You end up with particle behavior. Only two places the electron ends up. And then you remove the detector of in each, you just let electrons go. Do whatever you want, just shoot it, and then you will find interference pattern. That's crazy. That's crazy. So this is Davison Germer. Even if you only have one, you shoot it electron beams, you still end up with interference pattern. Interference pattern is dark light, dark light, dark light in your screen. You got it? That's more crazy because it requires electrons, one electron interact with each other. All right. So experience interference. Electrons also experience interference. While classical physics, our common interference only unique to wave, because only wave meets wave, wave interacts with other wave, create interference. Otherwise cannot. Electron with matter, no. Matter with matter, no. And Davison and Germer observe something crazy like what we just discussed. That's why we call it particle wave duality, one of the three foundations of modern physics. Modern physics founded by three principles. First, special relativity. Second, particle wave duality. And the third, I will not talk about this at this moment because you will get excited if you know the third one. 1905, Einstein said wave behaves like particle to explain the what is it, Dr. Lucia? Sinar menendang elektron.
Photoelectric.
Photoelectric. Thank you, Dr. Mark. You are chemist, but we are ashamed now. Oh no, we are physicists, but we don't. Yes, photoelectric effect. Photoelectric effect. Einstein said wave behave like particle. In 1923 and 2024, de Broglie, in his PhD defense, he said that, well, of course, long mathematical proof, and in the end he said, if wave can behave like particle, particles so behave like wave. And you know what happened? You can look up in the Wikipedia. The of his PhD defense confused. They don't know what to do. Mathematically, it does not make sense. So after 1 week of discussion, they don't have any conclusion whether to graduate, to pass, to give approval for de Broglie thesis, dissertation, or to reject it. One professor got an idea. Why don't we send his thesis to Einstein? Because his work De Broglie work based on Einstein hypothesis. And then they send dissertation to Einstein by mail because there was no internet at that time. So sending by horse. Okay, take a long time. And then at the letter, the book accepted by Einstein. Einstein read it carefully. Perhaps it takes like 1 month. From De Broglie from Paris. Einstein that time was still in Austria. And then Einstein replay black and then sending by horse again. And then accepted by the conference, the reviewer, and they open the letter. Einstein said, this idea is brilliant. Accept his dissertation. And De Broglie got his PhD because of Einstein's answer. Short letter, this idea is brilliant. Accept his PhD. No more discussion. Einstein already said something. It is like fatwa in that time. And finally, and at the same time, these two guys began their experiment, for measuring something else, but they got something else. So this is false Nobel Prize. There are two Nobel Prize got because of wrong measurement. First is Michelson and Morley when they tried to prove Esther, and they didn't prove it, but they got Nobel Prize because they don't. And these two guys measure something else, but they got the wrong result. And this wrong result, what they got, that electrons, they observe electrons got interference. So first, after they prove it, 1927, they published the result. 1929, De Broglie got Nobel Prize, and after few years later, these two guys got Nobel Prize. So De Broglie got first, and then after this year, these two guys got Nobel Prize. Sorry, I got my runny nose, so difficult for me to breathe. Let me take some water first. Jadi, adik-adik mahasiswa dari UNSUD dan dari ITERA, tahun 1905 ini Einstein mengatakan Bang memiliki perilaku seperti partikel untuk menjelaskan efek fotolistrik. Tahun 1923, 1924, setahun lamanya 1923, De Broglie mempertahankan disertasinya yang mengatakan rumus matematikanya panjang, tapi kesimpulannya adalah kalau gelombang bisa berperilaku seperti partikel, seperti kata Einstein, seharusnya lah partikel juga bisa berperilaku sebagai gelombang. Inilah yang kita sebut dengan partikel, dualisme gelombang partikel. Tapi ini teori saja. Jadi waktu pembimbing dan penguji disertasi De Broglie membaca, mereka bingung. Secara matematis tidak ada yang salah. Secara fisis nggak masuk akal. Setelah lama berdebat, ada satu profesor yang mengusulkan kita kirim saja disertasi ini ke Einstein. Kan dia bekerja menggunakan teori Einstein. Maka dikirimlah pakai kuda. Diulangi lagi, Dr. Vera. Sampai Einstein menerima buku itu. De Broglie di Paris, Einstein di Austria, di Austria, di Wina. Dia buka, dia baca 1 bulan, makanya 1 tahun lamanya sidang disertasinya ya. Kalau di kita ini sudah ganti topik nih, Dr. Vera. Udah kedaluarsa topiknya ini. Dibaca sama Einstein, dibaca pelan-pelan, dikomentari, kemudian dikirim balik surat jawaban Einstein. Pakai apa, Dr. Vera? Udah. Cuk, ada bunyinya ya. Sampai surat itu di tangan para penguji, dibukanya isinya cuma 1 baris, 2 kalimat. Idenya jenius, idenya brilian. Terima disertasinya. Maka luluslah De Broglie karena surat sakti Einstein. Begitu, that's the story. That's so many interesting, fascinating story during this time, Dr. Mark. In chemistry, perhaps before this, during Linus Pauling, But in physics, during this time, 1905 until 1940, many fascinating story. Unfortunately, I was late to born, otherwise I can contribute. I already knew the answers. If there was time machine, I will go back in this era and then I will tell everybody I know the answer. Anyway, so finally, using particle wave duality, we came out with quantum theory. What is it? If it is particle, we study it using wave equation. And if it is wave, we study it with using particle equation. Otherwise, if it is study it using particle equation or wave, we study it using wave equation, we call it classical mechanic. And classical mechanic governed by what we call causality law, hukum sebab akibat. In philosophy, we call it common sense. Akal sehat, bukan akal sahid. Common sense. That's causality law. But when we switch it, particle study using wave equation, wave study equation using quantum theory, it is quantum theory, and there is no common sense anymore, because common sense constructed by particle using particle, wave using wave equation. Excuse me, I need to. I hope I always show this figure to you, so you will remember very well. At least you can tell your friend that do not class. I know quantum theory already. This is quantum theory. You can impress your girlfriend, your boyfriend. I know quantum theory, and you draw this illustration. Don't forget to cite it is come from Mr. Febdian Rusdi. And for particle, when we study it using wave equation, one of the equation, many equation already, one of wave equation for particle is Schrödinger equation. And you do not need to afraid when you see it. How do you see this is wave equation? Because the solution, the red one, is a function depends on time and position. If you see function with the variable time and position, it must be wave function in physics. We are talking in physics. If you see a function containing variable time and position, the function wave function. There is no other function has that particular property. So that's why we know that this equation is wave equation because the solution is wave function. How do we know that the equation belongs to particle? Because we have mass here. Mass is the identity of particle. So the wave function here is the wave behavior of the particle mass m. That's how we read that. The wave function is the wave behavior of the particle mass m. Fungsi gelombang ini adalah perilaku gelombang dari massa m. Begitu Dr. Lucia ya. Jadi kita tidak perlu takut lagi dengan persamaan Schrödinger. Tapi make sure your friend is still afraid of this equation. So you print this equation quite big and show it to your friend and they will run away. So it is good for you if you want to have enough space for sleeping. Usir teman kalian dengan persamaan. All right, let's proceed. The common sense does not apply in quantum theory. Do not ask why. As long as it works, let it work. Do not ask why. Just calculate it. What is the meaning of the wave function? No meaning, but we need to interpret it. And one of the interpretation is C square, the wave function square, is the probability density function. Dr. Lucia, please take a note. page 17. I need to take it up, put it in the typo. So quantum mechanics make things indeterministic. Because of this interpretation, the C square, the wave function square, is the probability density function. Quantum mechanics makes things indeterministic. So that's why you have, when it comes to this slide, comes to this interpretation, you must remember of this figure. The huge debate between Einstein versus Bohr and the gang. Einstein alone, Bohr and the gang is like 10 or 20 people behind him. So that's make you understand how powerful Einstein was during that time. All of the people in the room were against Einstein. Einstein is only 1%. And he lose. Einstein lose the debate. But they still drink coffee together. That's the beauty of friendship. You don't have to agree for all issues, but friendship is always number one. Remember that. So one of our mission in join class to make you guys friend each other from Unair, from ITERA, and from UTM. You don't know the future. But I, Dr. Mark, Dr. Vera, and Dr. Lucia already experienced. Find in the end, friendship help you in your career, in your life, and so on. So one of the mission of joint class is to make you friend to each other. We will copy paste with Einstein and Niels Bohr model. You don't have to agree for each issue, for all issues, but friendship always number one. And finally, you know that this quotation from Einstein writing letter to Max Born. The theory produces a good deal, but hardly brings us closer to the secret of the All One. Teorimu bagus, tapi tidak mendekatkan kita pada Tuhan. Oh, ini Islami banget kan ya. Ilmu kalau tidak mendekatkan kita pada Allah, itu bukan ilmu yang harus kita pelajari. Ilmu harus membuat kita dekat kepada Allah. I am out all events convinced. Saya sudah sampai pada kesimpulan Tuhan tidak main dadu ketika menciptakan alam semesta. Dia tidak setuju dengan Born statistical interpretation. Dia setuju dengan quantum mechanics, yang dia tidak setuju bagaimana cara menafsirkan quantum mechanics. Lanjut. Then we have Schrödinger in mathematical perspective is really easy equation. It is just a second order partial differential equation like this. This is one dimensional. This kind of form allows us to split. This is T ya. Dr. Lucia, tolong catat slide nomor 19, typo lagi, harusnya T di sini ya.
Baik.
You split it becomes only function of time and function of space. I put it here is one dimensional to make it easy to see. And when you split, the wave function becomes two function, time function and position function. You will have this solution for function of time and time independent Schrödinger equation like this. There is no time anymore. There is no time domain in this equation. All of the quantity in this equation is spatial domain. Fungsi, posisi, fungsi, dimensi, ruang. Spasial, dimensi ruang. All right. Of course, we need to test this model. We need to test this wave equation for particle. And the real case that we need to test is hydrogen atom. How time-independent Schrödinger equation predicts the properties of hydrogen atom. We make simplification. We already discussed this the last 2 weeks. we are going to use one instead of two body problem. Hydrogen atom is actually two body problem, but we simplify it by saying there is no nucleus, so we only consider electron swims in the potential field of Coulomb. There is no nucleus. You will get surprised later on when you study the orbital of hydrogen. You know that orbital S, right? S orbital, S, Superman, S orbital. S orbital means the angular momentum is 0. If there is no angular momentum, it means the electron moves in the linear path. There is no back and forth. If it is back and forth motion, it has angular momentum. Orbital S, momentum angularnya berapa, Mbak Hanan? 0, Mbak Hanan ya, 0. Kalau momentum angular 0, Mbak Hanan, artinya elektron bergerak lurus, bergerak lurus. Nah, kita tahu orbital S itu posisi elektron cuma berada di dalam lingkaran. Bagaimana caranya bergerak lurus dalam lingkaran? That's the strange thing happen. Lingkaran, ini lingkarannya, tutup botol selingkaran, elektron berlari dari sini. Lari dari, kelihatan ya, Dr. Vera ya? Elektron berlari di sini. Oh, hilang tangan saya. Sini ya. Lari di sini. Lari, 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 lari gitu ya. Gerak, gerak. Sampai di ujung ini elektron hilang. Muncul lagi di bawah. Hilang, muncul lagi di bawah. Hilang, muncul lagi di bawah. Tidak hanya hilang muncul itu yang aneh. Ada lagi keanehan yang lain. Apa itu? Elektron boleh di tengah-tengah ini. Padahal di sini ada nukleus. Aneh, Pak. Memang aneh. Salah itu, Pak. Memang salah. Nggak ada yang mengatakan benar. Nobody say it is true. But that's how we explain the behavior of electron as wave. So, and then the second simplification, we say that electron is at rest. Electron does not move. Strange thing. Electron, of course, electron is moving. There is no way they are at rest. Because of these two, then we can use this formula. Electric potential from Coulomb, this one. And if we use this as an energy, potential energy, the solutions are Laguerre function. It is already there. Before Schrödinger equation exists, the solution is already there. Mathematician already has many functions. Up to now, we perhaps only 10% of the function in mathematics used in physics and chemistry. We still have 1,000 functions out there that still don't, up to now, we don't use it. And the second solution is the spherical harmonic function. And using this simplification, there are 5 properties of hydrogen predicted by Schrödinger equation, and they're all 5 correct with a very high accurate, no mistake about that. First, about Bohr radius around this number 0.529 Armstrong, and the radius of hydrogen is 1/2 of this Bohr radius, 1.5, yeah, 1.5. So that's why we call hydrogen atoms around 1 Armstrong. And then the ionization energy of hydrogen is 0.5 Hartree. This is Hartree. If you transfer change it into electron volt, it becomes 13.6 minus 13.6. Okay, I don't put minus here. And then we have line spectra. This is the equation. That's why this is how to explain the Lin series, Balmer series, Paschen series. And finally, number 5, we have atomic orbital SPDF that match with spectroscopy experiment. 5 properties of hydrogen atom predicted by time independent Schrodinger equation with wrong approximation. Why the wrong approximation can result in the good result? Do not ask why. It works, just let it be. Now we will see atom with 2 or more electron. But this is new material. So before we will continue, I will let you guys to sink a deep, think about that, and let me have a cup of coffee. Dr. Vera, can we continue?
Yes, we can continue.
Are you sure?
Yeah.
Bro, are you still there?
Yes,
Not.
sir.
Thank you.
Yeah.
Where is Dr. Mark? Okay. Oh, you wear your mask.
Oh,
Cool.
yes.
So everybody sick. Dr. Vera sick. Lucia sick. Lucia is always sick. Okay. Me also sick. Now we begin the new material, atom with 2 or more electrons. Dr. Lucia, please take a note. Slide 22 must be plural. Atoms with 2 or more electrons. Now, simplification 1. Using simplification 1, we get rid of nucleus. From 2-body problem, this is hydrogen atom anyway. From 2 body problems become 1 body problem by using simplification number 1. We get rid of nucleus. But now, if we have helium atom, the same method doesn't work. Look at this. We have helium atoms. We have one nucleus, A, but we have two electrons, 1 and 2. And this is origin, means the way we define the position of a nucleus A, or electron 1 and electron 2 by with this reference. Okay, this is just to show you that the position is a vector. Even though we use, now in this case, we have three body problem, one nucleus and two electrons. We will apply simplification 1, getting rid of nucleus. We still end up with two charges, two electrons, Q1 and Q2. So even though we reduce three body problem becomes two body problem, or in the specific term, we call it two electron system because our body is electron. It is not solve the problem. We still got a problem because now we have two body problem. Many ways to simplify it because we want to bring one body problem back to the table. Schrödinger equation only works for one body problem. I repeat it again. Schrödinger equation only have the exact solution if we use it for one body problem. Schrödinger equation only have the exact solution if we deal with one body problem. If it is more than one body problem, two body problem, three body problem, we don't have the exact solution. Exact solution means you don't need computer, you don't need numerical method, you only need pencil and wall, because Dr. Lucia liked to write in the wall. There is a song about that, write in the wall. I forget the rhythm. Okay, continue. Tangent. We try to avoid tangent. So one of the method to simplify helium is using shield model. What is shield model? You consider the nucleus and one of the closest electron to it, in this case is Q1, is one big system. So in helium, the nucleus has two proton, 2 plus 2 plus 2, and electron is minus 1. So you combine them together, you consider the electron is like a cloud cover up the nucleus. As the system cloud together with the nucleus, the total charge is plus 1 minus 1. Please bring up the calculator, Dr. Vera. Plus 2 minus 1 is equal to?
Plus 2 minus 1. Minus. Plus 2 minus 1.
Yeah, plus 2 minus 1 is equal to?
Plus 1.
Okay, plus 1. So now we have this big cloud as a one system with the charge plus 1, and the electron 2 is minus 1. Now we have hydrogen-like atom. Hydrogen-like atom. Jadi kita anggap nukleus dan satu elektron yang terdekat dengan nukleus sebagai satu kesatuan sistem. Elektron ini dia bergerak membentuk awan dan menutupi nukleus A. Sehingga si awan ini total muatannya berapa tadi Dr. Vera? Ini plus 2, ini minus 1.
It's 1 o'clock.
Plus 1. Sementara kita punya satu elektron di sini, muatannya adalah minus 1. Kita punya satu elektron, satu nukleus, mirip dengan atom hidrogen. Bedanya apa? Inti atomnya terdiri dari dua sistem, nukleus dan elektron. So that's why we call it atom seperti hidrogen. Atom, hydrogen like atom. Coffee again. We can use this model for many cases. All atoms can be approached by using this model. I say it again because I believe Dr. Mark will ask you in the quiz. Using this model, we can explain, we can bring one body problem back to the table for all atoms. You can simplify all atoms using shield model so that you can consider every single atom as hydrogen like atom. Beautiful. Finish. Khalas. I understand everything unless I meet molecule. Now the problem occurs. You cannot use it anymore. Why? Because one electron problem is the specific term of one body problem. One body problem valid for every terms like our Earth's, our galaxy, our solar system, our electron system, our atomic, molecular. But one electron is a specific term for one body. Yeah, one electron problem works perfectly because the potential energy is a central field. That's the keyword. Central field means there is only one sun in our solar system. That's a central field. Seperti di pemerintahan kita sering terdengar matahari kembar. Wah. Kalau jangan ada matahari kembar dalam pemerintahan. Padahal kalau matahari kembar pasti dia bersaudara. Mana ada kembar yang bertengkar kan? Hahaha. One electron problem works perfectly in the Schrödinger equation because the potential energy is a central field. Only one source of potential. Only one source generates the potential field. If we have molecule, like in example, in this case is H2 plus molecule hydrogen, but ionic, yeah, hydrogen ionic molecule, H2 plus, H2 plus. We have two nucleus. We have two nuclei. Dalam bahasa Inggris, plural dari nukleus adalah nuklei. Tapi dalam bahasa Indonesia, plural dan singular untuk nukleus sama. What about in Malay, Mark? What is the plural for nucleus in Malaysia?
I think it's the same as well.
Same, okay, good. We are brother. In molecule, the simple molecule, is there CC here? CC, are you there? No, no CC. Rizka-san, please give Rico access for co-host.
Yes, sir.
In molecule, at least we have two nucleus. Nuclei. We have two nuclei. Each can you see the balloon? Each nuclei generates potential field. You have two nuclei, you have two sources of potential field, and it is not central anymore because you have two suns. Each sun generates its own radiation. You cannot use central field here. That's why one electron problem, even though you approach it with shield model like before, it does not work in molecule case. Why again? Because Dr. Mark will ask you in the quiz. The question is why shield model does not work for molecule. The answer is one electron problem works perfectly because the potential energy is a central field, while molecule at least has 2 nuclei, and there is no way we can approach using central field. That's the reason number 1, not enough. If you only answer that, Dr. Mark will grade you half, not 1, only 50%. The other half is both nuclei cannot be at rest. They are vibrating. They are vibrating. You cannot simplify like what we did before. And when you ask, when we come to this term, the second reason, nuclei cannot be at rest or they are vibrating, then there is no way for us to forget about this lecture. You can type this using Google later on, Richard Feynman, and this is his famous lecture in Caltech for first grade, for first year. He volunteered to lecture Fisika Dasar 101. Fisika Dasar FI 101. He volunteered. He got Nobel Prize already, Richard Feynman. He got Nobel Prize in 1964. He volunteered himself to lecture the freshmen in Caltech, Caltech in United States, to lecture Basic Physics 101. And you know what happened? You know what happened, Dr. Mark? The audience, the attendants, the participants that came to the class were the lecturer, other physicists came to the class because everybody wants to listen to Richard Feynman. And the real students, because freshmen, they are afraid of their teacher. The teacher, go. We want to sit here. And finally, the students sit on the floor. Feynman was so famous that time. And of course, it is not correct. So, and the next meeting, the lecturer, Feynman, get rid of the lecturer. Oh, you are physicists already. Go. This is for student. And he only allows several lecturers, several physicists to attend his class because it is for students. So how lucky you are. And one of the students here is, do you know who? Okay, this is tangent. I don't want to go that far. So during his class, the first meeting, this is the first meeting. This capture in the first meeting. How do we know? Of course, there is a documentation about that. But in this photo, you can see that lecture number 1. You see that? Lecture number 1, September 26. The first meeting, September 26. So this is a winter semester. And the title is Atoms in Motion. He didn't follow the curriculum. Dr. Mark, he didn't follow the curriculum. The first lecture is about atoms in motion, not about besaran dan satuan. Not about besaran dan satuan. He talks about the real physics. And then what you see in this Physics 1 lecture. Here, 11 a.m. Tuesday and Friday. No lab this work until Thursday. So there is a practicum. Okay, this he wrote this in the beginning. It is his hands writing, and then of course this is in the middle of this is my own typing. Okay, this is not part of the picture. It is I type this. So what do you see in this figure? He was lecturing physics, but he began with chemistry. He begins with chemistry. Can you see what it was in front of him? The molecules. You're seeing molymorph. This is also molecule. I wanted to say to you guys, especially our friends from UTM, you are in the very precious jabatan. Jabatan chemistry is the best in the world after physics. Why? Look at Feynman, our idol, the best teacher in the modern history of time. He began his lecture from chemistry. From besaran dan satuan. What is besaran dan satuan? So, during his first meeting, he said that you can see it in his book. If, he said, if in some cataclysm, jika ada bencana alam yang dahsyat, all of scientific knowledge, semua pengetahuan ilmiah kita were to be destroyed, hancur, hilang, tak berbekas, dan kita sebagai manusia, and only one sentence pass to the next generations of creators. Dia nggak sebutkan manusia ya. Dan kita hanya bisa mengirim pesan. We only can send one sentence to the next creator, perhaps monkey. Bandarabat, Bandarabat, kota monkey. What statement will contain the most information in the fewest words? Apakah pernyataan yang sangat singkat, yang bisa memiliki semua informasi yang kita miliki sekarang dengan kata-kata yang sangat singkat? Ada jawabannya, dia jawab berikutnya, he answered by himself, but I put it in my own language, so it is a bit long, because it is for you. If it is in English, short. Perhaps Dr. Mark later can show it to you. So this is the most information in the fewest word. It is atomic theory. But not from Dalton. Not Dalton atomic theory. Feynman atomic theory. What it is? Again, he explained using chemistry. You see, it is hydrogen, oxygen, hydrogen. What is that? Water. Water. Everything is made of atoms. The first step, of course, in his book, it is only one sentence, but I split it into 3 statements. Everything is made of atoms. When too close, atoms repel each other. When far enough, atom attract each other. Segala sesuatu terdiri dari atom. Kalau terlalu dekat, atom-atom itu saling tolak-menolak. Kalau agak berjauhan, mereka saling tarik-menarik. It reminds you Bilasang and his boyfriend. Ketika Bilasang dan pacaran kan seperti itu. Pacaran itu haram ya. Haram, mana si Bila tadi hilang? Kabur dia, Rizka.
I'm here, Dr. Fabian.
Like you guys, when you are dating, when you are too close, you fight. When you are too far, you send letter, I miss you, guy. I miss you, girl. Stop that toxic relationship. Okay, this to explains to us vibration. That molecule are always vibrating. You cannot get rid of vibration. When you get rid of nucleus using our simplification in hydrogen atom, you don't have vibration information anymore, which is wrong. While we were wrong before, but it is too wrong, wrong quadrant. When you get rid of nucleus in the molecule case, it is so wrong. It is not tolerated anymore. So we have to find a method to keep one electron problem alive, even if it is for many electron systems. Even Dr. Lucia, this is also plural, page 29. Don't worry, guys. I will give it to you, this slide. Don't worry. So you can repeat to study at home. Let us see how do we approach this problem. We will use H2 plus, hydrogen ionic molecule, to understand how do we keep one electron problem alive. Why? We insist to use one body problem. Kenapa kok kita ngotot tetap ingin menggunakan one electron problem? Because Schrödinger equation only work for central field. That's the answer. Now I wrote the time-independent Schrödinger equation in the term of operator. Kinetic operator T, capital T, using copia. There is copia inside, you see copia. And Sylvie, Dr. Lucia, also I put copia here, or well, I call it jilbab for potential using copia and potential using jilbab. But I forget to put it. I'm really sorry. TA mean kinetic for A. TB kinetic for B. Because now we cannot ignore the vibration of nuclei anymore. That's the principle of atomic. T1 is kinetic for electron 1. VAB, there is a jilbab here. AB, kerudung. AB, interaction between A and B. A1, interaction between A and 1. And B1, interaction between B and 1. This is kinetic term. This is potential terms. And the wave function is the wave function for 3 body. Nucleus A, the position of nucleus A. Nucleus B, this is the position of nucleus B. And electron 1, this is the position of electron 1. If you can solve this, the solutions are the wave function of these 3 bodies. Got it? The solution of these 3 bodies. Of course, you cannot solve it. Remember, the 3-body problem cannot be solved. The famous example of 3-body problem that cannot solve until now is the sun, the earth, and the moon. That's why every Ramadan and Shawwal, we always fight when Hilal come. Yeah, especially Indonesia between Muhammadiyah and NU. In Malaysia, you guys very good. You only have 1 voice. But in Indonesia, we have more than 4 pendapat, 4 opinions. Now, people like Bila will always consider the latest Ramadan, the earlier Shawwal. That's Bila Sang philosophy. Why? We cannot calculate it. We always have difference. So the best way that there is no argument about that when we want to determine when is the Hilal, the new month, is to observe, to look at by ourselves exactly what our Quran says. Look at by yourself to compute. No need to fight. If you want to calculate, you always get some errors. 3-body problems. And you imagine that because our sun, our moon, and the earth, the mass is so big, moon cannot move from orbiting the earth to orbiting the sun. But if the mass is so small, like what we see here in the hydrogen ionic molecule, you can imagine this is our earth, our sun, and our moon. Moon sometimes can orbit the earth, and the next time the moon will orbit the sun. It is possible, resonance. But alhamdulillah, the mass is so big, it does not happen. But remember, guys, when we consider the resonance, it is the only way we explain it. There is no way for us to prove it happens, okay? Remember the common sense? There is no common sense here. It is just work. That's it. Anyway, we continue. Now, we have to get rid of 3-body problem. We have to get rid of 3 body problem. How do we do that? we use the adiabatic theory. We have to go to thermodynamics, adiabatic theory. This is our first. Look at, this is bilasang. Oh, exactly bilasang. Look at the hair. Oh, wavy hair. Unfortunately, this big figure doesn't use earphone. Next time I will put earphone here. Bilasang is holding a box. Inside the box, there is pendulum. You got it? Bilasang is watched by Hilal. Oh yeah, anyway, this is Hilal. Hilal. This cat name's Hilal. Hilal Nur Shawal. Hilal is watching Bilasang. Bilasang is holding a box. Inside the box, there is pendulum. And the pendulum is oscillating. Now, Bilasang walks. You can imagine that when she walks like a dancer, wavy walking, like a Jack Sparrow. And you know what happened to pendulum. The motion of pendulum will interact with the motion of Bilasang. You got the point, right? When the motion of this oscillation will interrupt it. The motion is not smooth anymore. But there is a time when Nabila are retired because she danced like a Mick Jagger, and now she is tired. But she's still moving, she's still walking, but really slow. Because Bilasang walks too slow, now the pendulum oscillates normally, smooth. So there is a time when the box motion is slow enough, pendulum does not know. Oh, sorry, Sylvia doesn't know, tidak tahu that the box is moving. Oke, Lucia, Sylvia. Ini air liur saya sudah habis ini. Saya ulangi ya. Teori adiabatik ini dari mana ilmunya? Termodinamika. Tidak seperti ini kami belajar teori adiabatik, Pak, di termodinamika. Ya, teori adiabatik yang kalian pelajari di termodinamika hanya secuil saja. Terjadi perubahan yang tidak bisa dikenali sehingga reversible proses. Jadi kan tidak kenal ini ya. Kata tidak kenalnya nyangkut ya, Dr. Vera ya. Jadi tadi si Mbak Nabila, dari mana kita tahu ini Mbak Nabila? Karena rambutnya seperti, saya lupa, alis mata seperti semut beriring, rambutnya bergelombang seperti astagfirullah, jadi tangent jadinya. Ya, dari mana kita tahu ini Nabila? Karena rambutnya bergelombang ya. Dia membawa kotak. Di dalam kotak ada pendulum. Pendulumnya mengalami osilasi. Dan apa yang terjadi kalau Mbak Nabila berjalan menari-nari, pendulumnya ikut menari-nari. Paham ya? Tapi karena Mbak Nabila sudah capek menari-nari, akhirnya dia jalan pelan-pelan. Dia pelan tinting itu si kotaknya. Akhirnya pendulum akan bergerak normal. Sehingga ini kata kuncinya, jika kotak tadi bergerak cukup pelan, pendulum tidak tahu kalau dia sedang berada di dalam kotak. Gerakan pendulum tidak lagi dipengaruhi oleh gerakan kotak. Dr. Vera, paham sampai di sini ya?
Paham, Dokter.
Nanti tolong jelaskan ke Dava dan kawan-kawan. Nah, konsep adiabatic theory ini mengingatkan kita, reminds us how the gravity works in the Einstein's general relativity theory. Jadi kalau when we learn about general relativity theory, I got A, from Groningen University, I got the class, I attended the class, I got A for general relativity. So once the time I know what I'm talking about, but not anymore, because I never use it. Menurut when we study Einstein's general relativity theory, this is the very good caricature. We are in the space, we are in the rocket. the left side of the rocket, it is moving without acceleration. So this constant speed. And here we are at rest. So every single physics in these two separate environments are exactly the same. We don't know that the rocket is moving as long as it does not accelerate. We still think that every single the rocket is at rest. So the speed of the ball, we see the microscope, we see the stopwatch here, everything is the same with the rocket is at rest. So this is also adiabatic theory. So when we learn general relativity theory, one of the section of the general relativity theory is thermodynamics. So thermodynamics is special knowledge, special ilmu khusus because it works for all of the genre of knowledge. Classical physics, classical mechanics, quantum physics, blah, 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 chemistry. Thermodynamic always works, never fail us. Anyway, it's always already 2 o'clock. Anyway, I'm in Osaka, so we have 2 different times here. Indonesia, Malaysia, and Osaka, 3 different zone time. We apply adiabatic theory to the time independent Schrodinger equation because now this is the box, A and B is box, and electron is the pendulum. Okay, A and B are boxes. They represents the box, while A, the one that oscillate from one to left, or from A to B, from B to A, we consider this electron as the pendulum. Dr. Lucia, you still can follow?
Yes.
So now we apply the adiabatic theory, Dr. Lucia. We consider A and B move very slow compared to electron. Electron move very fast. It is like a Rizka Sang comes to my apartment to eat from my refrigerator, move very fast. And suddenly she already opened my refrigerator without me noticing it. If it happens, A and B walk or move very, very slow, the vibration is very, very slow compared to what, Lucia? Or Dr. Lucia? To the motion of electron. What happened? We consider A and B does not move. A and B do not move. We do not see them moving when we see electron moving, because what electron will moves very fast compared to the motion of nucleus A and nucleus B. Okay, you got it, Dr. Lucia, because you need to explain again to your students. So we delete kinetic A and kinetic B, but left kinetic electron. We still have VAB. You see, jilbab AB, jilbab A1, and jilbab B1. We still there. So the electron is, the nucleus is still there. Nucleus is still there. We just consider that they do not move. So it doesn't mean that we delete them like what we did for hydrogen. Okay, Dr. Lucia? Because they are not moving, we remove position A and position B. So we end up with electronic time independent Schrodinger equation. Then the wave function now is the electronic wave function because there is no nuclei anymore. And the energy is the electronic energy, the energy of electron. So that's why when you open your Gaussian output, you will see electronic energy. And then total energy means electronic energy plus nucleus energy. You can open it and you can see it later on. When you need the nucleus energy, when you consider vibration. So when you deal with the reaction, chemical reaction, you always need nucleus energy. You always need that. So we call it 0-point energy. You saw it before, right? In the output goes. Now you know what it is. And the way the approximation that we just learned it came from Born-Oppenheimer approximation. Oppenheimer, the one that I put in the figure here, was the student of Max Born. Max Born, you know, the guy that comes with the idea of statistical interpretation. The guy that got letter from Einstein that God does not play dice when you are creating the universe. This is the guy, Oppenheimer. Please check internet, find it by yourself, or ask ChatGPT. This is for hydrogen molecule. This is for hydrogen molecule. Now we write it down like this: kinetic 1, electron 1. So this is hydrogen. We have nucleus A, we have nucleus B, we have electron 1, and we have electron 2. So we have 2 electrons now. Now we write down the time-independent Schrodinger equation for this system. There is no TA and TB anymore because we already use Born-Oppenheimer approximation. T1 for electron 1, T2 kinetic for electron 2, Gilbab AB for interaction of A and B, Gilbab A1 interaction A and 1, B2 interaction between nucleus B and electron 2, and so on. But even though we have 4 body here, 2 nuclei and 2 electrons, the wave function belongs to electrons only. But both of them, electron 1 and electron 2. And it is not, you know that it is not solvable. We cannot have the exact solution even though we already get rid of the nucleus inside the wave function. It is still not finished. For any molecules, we call it many electron problem. We have the total of electronic kinetic for electron, the total, and then the total of nucleus interaction plus, there is a Gilbab here, plus nucleus electron interaction plus electron interaction. Please, Dr. Lucia, page 36, I will delete G. But the wave function is the collection of all electrons. The wave function is the collection of all electrons. It is impossible to get exact solutions even for 2 electron problem. It is impossible to get the exact solutions even for 2 electron problem. Why? What do we mean by exact solutions? Exact solutions are like what we have for hydrogen atom, SPDF. Remember, orbital S, orbital 2p, 2px, 2py, 2pz, 3d, 3dxx, 3dxy, 3dxz, and so on. That's what we call exact solution. We cannot use the same method to solve 2 electron problem. Therefore, we must make another approximation. So the first approximation is adiabatic approximation. Oh, sorry, Born-Oppenheimer approximation, where they applied the adiabatic theory to the Schrodinger equation for molecule. We call it what? Born-Oppenheimer approximation. We need another approximation. So Born-Oppenheimer approximation, just to remove nucleus dependency of wave function. So we will have Schrodinger for electron only, wave function for electron only, and energy for electrons only. We don't consider nucleus inside our wave function, but we still have the problem because electron is more than 1. We still don't have the exact solution. We need another solution. And then another solution, we have many options like Hartree-Fock method, like couple cluster method, like blah, blah, blah method, but we will stick to density functional theory method that make every chemist happy. Hartree-Fock is good, but not really good. Couple cluster, oh, excellent, but expensive. DFT is the most balanced theory easy to understand, easy to compute, and the cost of the computation is also low. So that's why, inshallah, we will see DFT in action. I will explain to you the basic of DFT, and then the next session we will have 2 sessions next week. The first half we will have DFT in action, the last theory that you will listen to our class, and then we will discuss your results to understand what you have done so far, or we will focus module 1, of course, module A1, and we will be happy. That's all, guys. Inshallah, we will meet the next week. Thank you very much for your attention. We still have like 20 minutes before we end the class. Perhaps Dr. Mark would like to share, get some additional comment. Please, Dr. Mark.
All right. Thank you, Dr. Fabian, for the sharing. Let me just ask if there's any questions from my students. You have any questions? Yes, please. What's the question? Huh? It's okay, you can cakap je. I will ask. Huh? Ada? My students are shy.
Don't worry, guys. Kita akan bertemu Januari, inshallah. I will come to your lab.
They're clapping their hands. They're very happy.
No problem. They can ask you, Dr. Mark. Don't worry. Please ask Dr. Marks.
I think there's no questions for now. If there's any questions, I will let you know.
Please.
Yeah.
I will move now to Dr. Vera.
There is question from Dava.
Yes, go ahead.
Bahasa Indonesia tidak.
Salam Pung.
Assalamualaikum, Mr. Ferdian.
Waalaikumsalam warahmatullah.
I will ask to one body problem. Yeah, I still didn't understand what is the one body problem, and then shield method. And one question again, why the born Oppenheimer it delayed the nucleus in wave function?
Very good question, Dafa. One body problem. When we call it one body problem, I will go to this slide. Where is it? No, not this one. Where is the Schrodinger equation? This, you see this equation, Dafa? You got the wave function, right?
Yeah.
The wave function depends on how many position, Dafa? 3 position of, you see that? Position of nucleus A, position of nucleus B, and position of electron 1. Okay? How many body is that, Dafa? We have nucleus A, we have nucleus B, we have electron A. How many person is that?
3.
3 person, right? We call it 3 body. You got it? When we go back to hydrogen, where is it? Hydrogen. This is hydrogen. This is hydrogen. We have 1 nucleus, 1 electron. How many bodies is that?
2.
2. But when we delete the nucleus, we only left with 1 electron. How many body? 1. So when we write the equation, the solution, the wave function for case A, the solution, the wave function, depend on the position of nucleus A and the position of electron 1. We call it two-body. The wave function depends on two persons. For case B, we only have one electron. So the wave function is the function of one electron only. Depends on the position of one person. We call it one body problem. So you know now, you see the wave function, you count how many variables, the position variables inside the function. That's determine how many body you deal with it. Kita lihat saja fungsinya tadi, Dava, bergantung pada posisi berapa benda. Kalau dia bergantung pada 3 posisi benda, kita sebut dia dengan three body problem. So far is good?
Yes.
So far so good?
Yes. So far,
Okay.
all.
Good. Alhamdulillah. Now we move to Born Oppenheimer. Ini siapa ini, Dava?
Nabila San.
Ya, Nabila Sang. Mana Nabila Sang kok hilang? Hilang terus dia kalau kita panggil. Tapin lah dia lah. Mana dia tadi? Oh, ini dia.
I'm here.
Merah pula mukanya. Mbak Nabila malu pula dia. Sayang Mbak Nabila nggak mau ke Lampung kemarin. Jadi insya Allah Dava dan kawan-kawan ITERA bulan Februari atau Maret nanti we will have boot camp. Boot camp. We will conduct perhaps 1 week in the hotel, in the meeting room. We will finalize our manuscript together in Surabaya. We will invite several students from ITERA. Also, I will expect more Mas Wildanul also come. And Dava, Mbak Nabila nanti akan menjadi event organizer. Jadi Mbak Dava bisa kenalan langsung nanti dengan Mbak Nabila. Si merah pula muka Nabila ini. Ini Nabila. Nabila pegang apa, Dava? Pegang kotak. She is holding a box. Di dalam box apa? What is inside the box, Dava? Pendulum. Pendulum is oscillating. Dia sedang bergerak maju mundur, berosilasi. Ya, Dava ya. And Dava, you must know, you know it by common sense. The motion of the pendulum depends on the motion of Mbak Kak Nabil. Berubah lagi nama Nabila sekarang Nabil pula. Tambah bagus namanya. So the motion of the pendulum is influenced, dipengaruhi oleh the motion of Kak Nabila. Correct, Dava?
Yes.
But there is a situation, Dava, where whatever Kak Nabila is doing does not influence the motion of pendulum. There is a situation, ada kasus, ada situasi, apapun gaya Mbak Nabila, Kak Nabila tidak mempengaruhi gerakan pendulum. What is the situation? If Kak Nabila moves very, very, very slow.
The pendulum is still oscillate.
Yeah, but the pendulum does not know Kak Nabila is moving because she is moving carefully, like when Dava is holding a bascom, you know bascom, right? Full of water. Bascom full
Yes.
of water. Now Dava moves running. Dava berlari, pasti airnya tumpah. Tapi kalau Dava berjalan sangat pelan, air di dalam baskom bahkan tidak bergerak. Dengan catatan Dava harus tahan napas. Napas Dava kan keras. Ya akhirnya tumpah karena napas sendiri. But our story is not that way. Paham Dava?
Yeah.
Air tidak bergerak kalau Dava bergerak sangat pelan. Itu namanya teori adiabatik. Begitu Dava bergerak sangat pelan, begitu Kak Nabila berjalan sangat pelan, kita pelajari pendulum ini dengan mengabaikan Kak Nabila, walaupun rambutnya bergelombang seperti apa ya pepatahnya ya? Alis mata seperti semut beriring. Cari Mbak Bu Vera, lupa saya. Inang terurai apa ya? Paham, Dava? Because Kak Nabila is moving very slow, what happened, Dava? We can study the pendulum's oscillation without considering, tanpa mempertimbangkan the motion of Kak Nabila.
Okay.
Paham?
Yes.
Now we move to the hydrogen molecule. Okay, we ignore this. We move to the hydrogen ionic molecule. Which one is the box here, Dava? We have two kind of body, nucleus and electron. We have two nuclei. Which one is the box? Which one is the pendulum?
The box is A and B.
Good, very good. A and B is the box. Good. And A is the pendulum. Why we say that? Because in this case, pendulum is inside the box. Pendulum cannot go outside the box. If we go to this figure, the hydrogen molecule, electrons is inside the potential field generated by A and B. Electron A, electron 1 cannot move very far from A and B. So A and B is like a box contained, mengurung electron. Now electron moving very fast. The speed of electron is much larger than the speed of A and B vibrating. Oke, sampai di sini, Dava?
Okay.
What is the adiabatic theory told us? If A and B work very slow, we can study electron 1 without considering the motion of A and B. According to the adiabatic theory, if one moves much faster than the moves of A and B, Dava, you still know?
Yes.
Kalau satu bergerak lebih cepat daripada A dan B bergerak, according to the adiabatic theory, we can study the motion of one without considering the motion of A and B. When you ignore the motion of A and B, what happened to the kinetic of A and B here? You remove it. Okay?
Okay.
Since you remove it, the wave function does not depend of the position of A and B anymore. It only depends of the position of electron ones only.
Okay.
So that's the answer for your question, why we can remove kinetic A and B and the position dependence of A and B inside the wave function.
Mr. Fabian, after you explain the adiabatic theory, I would ask again, why the nucleus is very slow?
Good question. I didn't explain anything about that. Very good. The mass of electron and the mass of proton is so big in difference. One proton is equal to 2,000 of mass of electron. One proton, the mass of one proton is equal to 2,000 of mass of electron. You can imagine that you have one proton, one electron. The proton is like a sun, and our electron is like a moon. So big in comparison. Like in our solar system, we always consider the sun is at rest, diam, but it is not correct. Our sun is moving a bit. One of the problem of the three-body problem because of there is no single body in the three-body is at rest. All of them is moving toward each other. Okay, Dafa, I don't want to go to tangent.
Okay, thank you, Ms. Fabian, for your answer. Thank you.
Thank you, Dafa. Okay, Dr. Vera.
I think that's all from us.
Thank you. We go now to Dr. Lucia.
I've asked them in our WhatsApp group and they say they have no questions for now.
Alhamdulillah. Alhamdulillah. All right, guys. Before we conclude our lecture, it is 2-hour lecture now, though it's really long. That's why usually I will only use 1 hour, right? But it is really difficult subject, and we hope you guys enjoy it. No need to hurry yourself. Every single of you has your own way to study. Use it. I will deliver the presentation to Dr. Mark, Dr. Sylvie, and Dr. Vera. You can spread it to your students and continue your module. Next week, inshallah, we will conclude everything with density functional theory for 1 hour. And the last 1 hour, we will discuss about your module A1. And during that time, Dr. Vera, Dr. Lucia, and Dr. Mark will make a timetable when you have to submit your report. Because we want, guys, when we, Dr. Vera and myself, visit you in UTM, we will grade your module as much as possible. And please make a dua so Dr. Vera will sing for you. We don't know. Last year she sings, amazing. We didn't know that she likes to sing, and we hope she can sing later on in UTM. Please, Mark, provide a good sound system. All right. Please turn on your camera. We will take a picture again. Thank you, Shiva. Thank you, Widanul. Hanan, Mbak Hanan, thank you. Please, guys. Anissa, tolong nyalakan kamera. Gabriel. Terima kasih ya atas kehadiran kalian. Mana Riko? Riko, please take picture.
Baik, Bapak. Baik. Gabriela sudah siap? Baik, 1, 2, 3. Sekali lagi. 1, 2, 3. Sudah, Bapak.
Terima kasih. So we will conclude our class with doa penutup majelis. Semoga kalian senang dengan kuliah ini, terinspirasi. Sayang sekali saya tidak jadi berangkat ke Purwokerto ya karena saya sakit. Tapi insya Allah sepulang dari Jepang, sekitar akhir Desember, saya akan sempatkan ke Purwokerto ya Mbak Hanan ya. Insya Allah kita akan ketemu dengan Mas Widanul juga. Subhanakallahumma wa bihamdika. Asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaih. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh. Sudah selesai acara kita. Please turn on the camera. Sorry, the video. You can leave, guys, because I know that Rizka Sang will. Apa ini Kak Nabila? Rizka Sang, jadi ada pertemuan?
Jadi.
Ya. Dr. Bark, we will stay in this room because we will continue the next meeting. Apa Riko?